Good afternoon, everyone. So if you're at the panel, you probably heard some introduction about me. But before that, I really thank you for spending your Sunday afternoon with me and trying to learn about what we have done so far in this space. But as I said in the panel, my background is more on AI and machine learning. And so I ran into Python when I had to deal with some of the social media constructs. And so here we're going to talk about a system, the application of that is going to be at a higher level. This is going to be slightly different than the sessions that you have seen so far. We won't go too deep. I'll give some examples of some code and so forth. But I want to talk about what all you have learned in the last 3 days, how to make business sense and business value out of it. So this experience I'm going to share will specifically address those kind of things. So I term this as hashtag buddies, but primarily the goal is you're trying to answer this question, right? So if you work in enterprises, a lot of times they have premium customers. So if you look at it, the majority of the value that the company gets is coming from those premium customers. So a lot of companies that are sophisticated in terms of how they manage data and how they understand their customers, they apply several nuances about their customers. Like, for example, they have knowledgeable business intelligence reports and so forth to start with, so that when you walk up to a customer terminal or whatever, they know oftentimes more about you. But in the last few years, that activity has gone a little higher up. So now they apply complex machine learning algorithms to identify, for example, what are the preferences that you have when you do certain things. They can pinpoint to specific actions for you so that they can send the right promotions and they take care of your issues and so forth. But the question that a lot of my clients ask is, all right, I've gotten that button down. I know my premium customers. I know what I can do for them. But is that enough? What can I do with that knowledge to do more, right? And that's the kind of question that we have. So if you have been in those kind of environments that I got my output from the machine learning algorithms and whatnot, and I'm using that to make something's value for my customers, what more I can do? That's a gist of what I'm going to talk about. So here we have a notion of, conceptually, how do I see these customers as? So if you put the social media interaction, your customer is a person interacting with a lot of things, right? As we said earlier, they are talking to your business by making some purchases or making something else. And they also do a similar thing with their competitors, right? And they may have other entities that they interact with, maybe some social activities and so forth. But there is a significant thing that has changed in the last 5 to 6 years, is the social media integration or interaction. So if your customer is interacting with your competitors, you have no information about that data. You may have your partner data, or optionally other data may be there, but now you have the opportunity to know what they're doing through the social media integration. So what we talk about is as a customer plus models, if you will. So this kind of mimics the concept that I talked about, right? So these are the transactions that what they do with you. And here are the social media conversations. So a lot of times when you hear the term that people build customer models, what they're talking about is this. They're talking about what I can learn from the transactions. That's what typically people talk about as a customer model. But what we are talking about is the next level of how you take as a customer plus models. So you think about that here is the integration of the conversations that people are having with, right? So it could be from some customers that are outside of your customers. So how can I find more of my premium customers? Can I use the social media conversations to get there? And the answer is yes. And how do you do that? So some of the adoption approaches that works well with our customers is this. Typically, you do want to define, before you bring in these methods and algorithms to yourself, ask this business question. What are my core capabilities that I'm looking for in my customer plus view? right? First of then it can tell you whether that information is gleanable from either your social media or other data and so forth. So you got to have that objective clear. And much to what we learned in the last few days, you will know that the technologies that they're talking about are not well proven in the sense there are a lot of learning curve that you need to have. If you put your head in an enterprise scenario, the enterprise class systems are not easily changeable. Right? You have your source systems are collecting your transactions. They have very predetermined structure, and you can't change them, what happens. And there are several layers of transformation that happens. So you have to define that. So how do you introduce such new esoteric advanced analytics concepts is, we all know that, it's very using a proof of concept. What I'm saying is in a lot of our enterprise class customers, this approach seems to work. So you've defined a very small test, if you will. Hey, I'm going to work only with the Twitter data, or I'm going to work only with my Facebook clients who have interaction with me, and so forth. You define that clearly. And of course, then once you run the POC, then you can evaluate, did it meet my results, and what are my scalable paths? So you may learn from your POC that the sources that I'm looking at, the models I have chosen are not working correctly, so I have to tweak something. And so what happens is you have a very defined method of approach. So this has become very important in an enterprise class scenario. So what do we do typically is, in order for you to go to the customer plus models, what we say is the first thing you need to have is, do I have my customer models built? It's amazing, you'll find out a lot of organizations, though they have good amount of data, they probably don't have a well buttoned down models of customers. They do have in pockets. They know certain things about certain customers, what works, but it is not well mature. So you got to ask the question, how mature is my current customer models all about? And then, obviously, we're going to talk about social media data, so you need to have some ability to process unstructured data. That involves, okay, do I have my current systems, like I may have only a relational databases. Is that enough for me to handle the unstructured information that I'm going to get? Or do I need to have some platforms in place and so forth? And why I'm saying all that is it takes such a complex steps in an enterprise scenario if you don't have all these things nailed down in the beginning. And obviously, somebody asked this question earlier. All right, I got all the NLP stuff done correctly, but my issue is I'm not scaling. So what it tells me is the planning wasn't done correctly, right? You got to think about what are my scalability requirements that I need to worry about. Let's say if I'm looking at Twitter, and we know that the tweets are coming in millions and millions so fast. So we got to figure out what are my strategy that I'm going to scale. When I define my proof of concept, am I picking the right platforms that's going to give me scalability? Am I picking the right libraries that allow me to partition the problem in such a way whether I do as an application manager or developer or the systems themselves can do? When they scale, what is the fault tolerance? Do I need to worry about if there is a problem in the code? Do I need to worry about fixing that as part of application or as part of infrastructure or as part of anything else? Let's say you may use third-party libraries. What is your integration strategy, right? So you have to think about all that stuff. And then, obviously, you'll find out some examples. I'll show you that there is, because it is social media data, there is a lot of fuzziness about what it means and what it does not mean. Because even though there are packages that implement NLP, NLP is not done correctly. You have a lot of context, contextual information that is not available to the computer that you're dealing with. So you have to expect some kind of fuzziness, and so what do I do that? Even if you use two NLP algorithms, you'll find out that they are not exactly the same way, and you don't have expertise to implement the NLP constructs yourself, so you have to rely on these additional packages. So how do you triangulate all of them to get to the core set of information? So these are the key things that stumps when you start to engage in this path. So let's talk about how do we build the customer models, right? So I mentioned in the panel that we do something called a multi-strategy learning. That's precisely the reason why it's very complex. Because if you take a look at your regular structured transactions, some have categorical values, right? It could be I'm picking this product, right? There is no order to it. I've just like a category, right? Otherwise, some have numerical information. There's an order to it, and there's a range to it, and so forth. Some may have your location information. You have to put two things together to figure out where it is, and there are other additional relationships that can be applied to. So the data comes in several, I'm not talking about the formats, but the data comes in several formats and meaning. So typically, in order for you to get the best out of this data, we do something called multi-strategy learning. What that means is, so you have your enterprise data available in multiple types of databases, right? It could be in MySQL or Oracle, Teradata, or what have you. And then, obviously, the ubiquitous Access and Excel. It's amazing how many large enterprises still do a lot of work in those things, right? So you have to deal with that. I see some heads nodding on the audience, right? And every now and then, you may have some conversations, right? There may be some customers, when you have your call center reps, maybe making some notes. So that information is available. 5 years ago, if you built a data warehouse, you will never store these conversations in your data warehouse. You always keep them separately, right? Because your systems are not geared up to deal with that. Now, if you're going to try to build your customer model without the social media, with just what you have in your enterprise, now you have to deal with that from a historical perspective. You may be building a model of, what is my churn rate? What do my customers do before they leave my business? So if you want to find that, you need some historical analysis done, right? So you have to deal with all these kind of various, structured data, unstructured data in different places. So you take that and apply several. I just gave you about 4 or 5 here. One talks about clustering. This is about, I have several data points. I'm going to find out who are all, do similar things, right? It could be saying like, okay, in this cluster, here is the median income, or in this cluster, here's where they live, and so forth. There are some, cluster you form. But is that enough to know more about customers? Obviously not. So you apply additional algorithms like decision trees. These are, they are called supervised learning. Basically, you say for each interaction or a transaction, you say, hey, this is a good interaction, or this is a bad interaction, or average, or what have you. So you have some domain expert giving you some classification of how these look like. So you run through these decision tree algorithms. They give you a decision tree, basically, that says, hey, if this happens here, and if this happens here, there are chances that this event is going to happen at this confidence and support and what have you. So you may be able to pull some sequential information together, which is very important in a churn analysis. The other one is, again, I just jumped into that. So the sequential analysis talks about what time frame you associate with that, the temporal information, so that you can predict some event based on some events that are not directly related to that, right? So you have that information now. And then, obviously, the neural nets are a very unique beasts, if you will. Basically, what they do is you send this information back, this unsupervised learning. They form a decision network, if you will, so that when a new information comes along, they tell what are expected outcomes from what I see now. So you form the neural nets. So basically, when you have models from all of these 4 or 5 machine learning paradigms, you send any new input that is coming into all of these models, right? And they produce results. And that's what I have understand as a learned rules. So what you do is then you have a best possible decision that you can make based on your events. Now, as and when more models come into being, you can integrate into this space. Now, the challenge is generally each one of these results are coming in different formats. So how am I going to triangulate that? One of the things that we do is in this particular approach is we converted all of them into what we call as a production rule-based language, if-then-else kind of thing. right? If you look at Fair Isaac or whatever, they have information coded like if an event, then an action. And there are some various, you can give some priorities and what have you. So convert all of the learned knowledge into one centralized rule-based engine. That is your decisioning engine, if you will. So what happens is any new information that comes in goes into the decisioning engine. And so what happens is when you see an event, you can respond to that. This is a very sophisticated customer model building activity. And now it is not impossible. You have several tools that are available. I heard someone talk about in the lunchtime, they said they use SAS a lot. Even the panel talked about SAS. It's a very powerful data mining software. And there are a lot of open source stuff available too. So you can create such sophisticated knowledge about customer. So that is the starting point for the next work. So what you do is you extend the customer models using our hashtag buddies approach. Basically, I want to keep that a very conceptual, in a very simple way. You source your conversations and organize them, right? And the way you do that is, I'm going to use tweets as an example, but it's applicable to many different things. You can see in tweets, you have this notion of hashtags, which the users of tweets are telling to you that, hey, here is how I am viewing this conversation as. Here is a clue I'm giving to you about what I'm talking about. Here is why I want my conversation to be associated with. This is what the tweeter, the person who is tweeting, is talking to you about as that's what I want to do. So it's very important to understand that. And then you process conversations using, we'll talk about two things, natural language processing and topic modeling. I kind of divided it into two. That's primarily because of the tool sets that I'm going to using that for that purpose. And once you have processed these conversations, it's important to find out how I'm going to build my buddy network. That's the key part of why we are doing all of that. The goal is we would like to form associations between various activities and by these people, and so that I can take my customer model into customer plus models. All right, so let's get some details here. So here are, I've put in the top here the kind of tools that I'm using. And in the middle row, it says what the concept is, and then there are some details. So to source the tweets, we use Twitter4J. There are many ways you can get tweets, but we just picked that because it was early available and so forth, and we were Java focused at the time, and so that's what we do. It can stream tweets, and there are many ways we do. In the previous version, we collected all of that into files. We just moved that into Hadoop and went on, but we are changing that to use streaming, so that it directly goes into Hadoop, so that it can eliminate the disk. The important thing about all the performance thing we heard is the less reason why you need to go to disk, the faster you're going to get. And we do some processing in that Twitter4J process, and it's very minimal. We'll talk about what that is. But primarily, his job is to go through API, collect the tweets, do the minimal processing, put it in a file, and that's it. The next one is, we would run the tweets that we gathered through the NLTK components, right? So what I'll be doing is we will identify the language of what it is. In the Twitter space, when you open an account, you tell what language you're going to be using. Like you have the information, that Twitter provides that. I have seen some cases where people say English, but the language may be something else. But there are NLP components that you send a string to it. It'll give you what language the string most likely matches to. It's fairly good. And then we also want to extract from the tweets the named entities. These are people, person, like organizations, and stuff like that that are appearing in the text. So the goal is you're trying to find out what are my premium customers are interacting with or talking about, right? Let's say if they're talking about a particular company or a particular place, you want to know what that is. So the named entity extraction is a concept that identifies these information for you. And then parts of speech. You want to know the verb and all that kind of good stuff. I haven't forgot to put here, but we also find out two other things which are expensive from a computation perspective. So we have an option to turn on and off. One is the dependency analyzer. It's that's what you were asking earlier. It's a tree. It tells that what is it grammatically, what's the structures, and what the sentence is, and so that you can find out what are the typical ways in which my customers are talking to. Some organizations, though we don't do that, but some organizations actually use that to figure out how they need to communicate with you. What is the style of speaking that you do? So they're going into that level of understanding about the dependency structures and so forth. So all this computation takes a long time. So what we've done is we initially started off with a simple code, but then we had to figure out a way to scale that up. So we converted it into MapReduce paradigm. In this case, if you look at it, I get a conversation. I identify these things, right? Language, named entities, and whatever. So if you look at it, everything happens within that particular conversation. I don't have to go anywhere else, right? It's all self-contained. I do load into some information, right, to help me with that, but that's about it. So a lot of stuff that we do in this stage, we do completely in the mappers. We don't do reducers much other than take and store. To briefly talk about MapReduce, do everybody here understand what it is? Okay, good. So they help you to scale into Hadoop space, and so that's what we do here from a mapper perspective. So the next phase is once we have identified these information, we're taking it to the next level, right? Here I know what they're talking about, whom they're referencing, and what type of language they use. But what I still don't know is conceptually what are they talking about. This goes beyond sentiment analysis. So we apply topic modeling. This is still a very esoteric concept. Basically what its goal is, when someone writes something, they have a concept in their mind and they translate that. So there is a theory that says, I can take this collection of words, try to figure out what is the most probable thing they're talking about. So when I say topic modeling, it looks like as if it's going to come out with a good topic that you can understand, but in reality, it'll be like a bag of words, if you will. So now you have a summary of what happens in this conversation. That's what we're trying to get there. So basically, all these conversations, we group that by hashtag. Earlier I said that people who are using hashtag are telling everybody that, hey, I am talking about this, right? That in itself gives you some idea about the topic. You take that to the next level. So we apply the LDA and GIP sampling based modeling. We use a package called Mallet to come up with the potential topics. In that particular stage, we do both mapper and reducer. So you can see that this is a streaming part. This is the first stage of my MapReduce, and that's the second stage of my MapReduce. Today we do that all manually, like in script based. But yesterday we heard about a system that can help you to schedule and all that stuff, but it doesn't work on Hadoop default. It works on Amazon. So once those things are available, you can orchestrate this kind of stuff much better. So in this case, one thing I do is, and as I talked about, there was a lot of question about performance, right? Since the text is pretty involved in the processing, we would like to apply, I gave an example about from a domain perspective, minimize the amount of information that you're moving around, right? So the mappers do the projection of, of these 1,000 columns or 1,000 elements, I'm looking only for these. And that way you make your stuff very precise of what you are trying to do.
Typically, how many tweets do you have?
So good question. So I gave an example, right? There are billions of tweets. So what you do is when you look for your particular search term, right? I've seen anywhere from 150 to 700 million tweets. Depends on what you look for, and so a lot of times you have a good judicious use of the search terms, and that way you minimize the amount of stuff that you want to process. But more than half, I don't have exact number, more than half the tweets are people are trying to advertise stuff, right? So you filter as much as you can before you get here. I'm not doing that in this space. That is before I get into my MapReduce, we have a lot of cleansing things we do, and so that eliminates like a lot of URLs. We take all that out because they don't. You just want to know what URL is. In some cases, URLs might make sense, but you will see quickly that there is a lot of patterns that you can eliminate, and so that way you can minimize the workload. If you're not doing that, in the beginning we were not doing that a lot. So our scalability was not as high it was, but there are some research papers available. It's interesting that people use Twitter information for a lot of stuff. So a lot of papers have some information about how do you eliminate specific things away from the tweets, and then you can clear that. The other good thing about NLTK is the taggers and all that. If you use a default tagger, they're going to tag everything in whatever that way. But you could train the taggers to do certain things with Twitter. For example, there is no notion of @mention in English language, right? It's a Twitter thing. So you could create a chunk to say, okay, whenever someone says @something, you treat that separately. Don't do anything like, he's trying to find what kind of tagging it is, right? He's looking for all possible tags. So you don't want to do that. So you can fine-tune the tagging part of NLTK by training that. So you learn all those things that we need to do before it becomes more scalable. All right, so let's get some. In the spirit of this conference, I have put some code in here. So we won't go into detail, but the key thing that I'm talking about from MapReduce perspective is that the challenge is you have to figure out from your conversation perspective, how do I convert that into my key value pair? So that's what this is. So in my case, in this example, the key is the hashtag. See, the point I'm trying to figure out is I'm going to split these conversations by hashtag, right? So that's my key. The payload is, there are many things that I just shown a small part, but it could be anything. In my case, we talked about the POS tagging, the dependency analyzers information, and the named entities. All of that goes into my payload, which goes into the reducer thing, and it does what it needs to do. Okay, so that's a simple way. In Python you can write a MapReduce code, and then here is the example of how you could deploy that. Let me see if I can walk that through. Basically, this one is the streaming jar that you need to provide for Hadoop to take the mapper and reducer code into the right nodes for you. So you say that what file contains the mapper topic, the mapper code, and then you declare that has to be the mapper code, and same way. So the Hadoop system will distribute this to the several nodes and then run the process for you. Okay. So here is an example of what I'm talking about. So this is an actual tweet I pulled out of the system, and this is remember I mentioned earlier that the Twitter for J that's what it produces output as. So it basically, this is the time in which it happens, and then who did it, and what the actual tweet is. Everything else is that I compute certain things about what it does, whether is it a place mention, or whether the profile of the Twitter has some information. If it is there, it'll say. If it is not, it'll put false or whatever. So that's the kind of stuff that it puts out. Okay. So the key thing we're going to working on is this tweet part itself. So here is an output of what happens after it went through all the processing. So the way I've done that is, so you saw in the earlier screen what the Twitter for J component produced. So I take that and extend the information with these things, right? So convert that into database-centric date so that I can do something like that. And then it talks about the @mentions and so forth. And then if there are any hashtag in the tweets, we pull that out separately, and the voice, say Rob or whatever. And this is the original tweet, that's what it is. And here is the what I call as a POS tag. So here's how it looks like. So it takes each one of these symbols and then says what it is, like a noun phrase or verb and all that kind of stuff. Okay? The red part is the output of how a POS tagger will look like. And then here is the dependency tree. You could actually draw a tree if you have a network, but it tells that what structures are there. The way to use that is you are interested in, let us say if you are looking for a known grammar or a known structure of tree that you're looking for, right? Because remember, this is a conversation mapped into what it is. But you have built models that you're looking for. I'm looking for this particular tree. So you superimpose the tree that you're seeking into the tree that it produced, and there is your match. That's what you're trying to do. But this is just information. And we talked about named entity recognition. This is the named entity. It says, sometimes you can see how horrible it is. Like say RT is organization. It isn't, right? But I use a default tagger, and so what you do is, I just want to show you, if you use a default tagger, there are some false positives. And that's the reason why I mentioned that no matter how perfect you get your tagger, with the Twitter space or social media conversations, you got to be prepared for some element of unclean data, which I call fuzziness, to be precise. Okay, we'll give an example of how two different things work there, okay? So once this information is available, this is what actually gets filtered and gone into the topic conversation, okay? So let me give a little better example in terms of how the NLTK works and so forth, right? So here is another tweet that I pulled from here. So typically the way you do that is we convert that into tokens, right? It all starts with that little piece of thing that I want to do. So it'll break everything into these tokens. And then you can simply say, OK, I have a pause tag method available. So I call that. And here is my tagged output. OK? So it's as simple as that. That's the beauty of the NLTK packages where you don't have to do a lot. It's readily available for you. And OK, so let me go back here. So all right, so this is fine. What I want to show you is, what we started off was using Stanford NLP Java-based libraries. But when we started to use the out-of-the-box thing from NLTK, you can start to see the differences here, right? It tagged as a person, right? And here, where is that? Yeah, NNP. So it's just that the name, how the terms, what it uses, are slightly different, right? That's about it. But you can see that LAX, right? The NLTK tagged as NNP, but the Stanford tagger just said, I don't know. Always I don't know means it is not tagged. So you can train this to learn those kind of things. And then you can see that Los Angeles, it identifies location correctly. I think this is I think it's called GP is for location. It talks about geopolitical event. Geo tagged in there, right? So that's how it tags correctly. So what you need to do is, if you want to get the best out of it, you train your taggers. Even then, we always prefer that if you can have multiple passes at your data, you get the best possible answer, and basically you're trying to make a decision based on these unknowns, and you would like to eliminate as much unknowns as possible. And that's the reason why we believe in the multi-strategy based learning of running this in two different ways. OK, so once we have done with that, once you have that kind of detailed data available, you run through the next stage of process where you run through the topic associations, right? So I got the topic model and built. And obviously, the way the topic model works is it takes the conversation, and let us say if I say, I'm asking the topic modeler to find out at most 10 different topics, right? And it's going to find out 10 topics because I said so. And it's going to assign a score to this conversation. OK, this conversation has 0.90% association to this particular topic and 80 to this and whatnot. So you order that and figure out what is my top 10% of that. So you can see a lot of uncertainty and fuzziness is getting built into the system, right? So that's the challenge. And then once you're done with that high-ranking information, you have person to person, and here is what they talked about, and so forth. You start to build a buddy network. So we use Python Network X for that. There was a question about the scalability. Yes, certainly does not scale very well. But the way we did is we had multiple networks of independent networks. And so our goal is you can have a hierarchy of networks. Those things are possible. And then you can run a different sets of algorithms on different layers of within the network. And so we use networks to do that. And once we have the network structure formed, you could derive a lot of associations. So let me see if I can show an example here. So here is how we can read the end buddy network looks like. Say, for example, what it says is this person is tied or associated with this person based on what they're talking about, like Gardner and Brett, whatever. And then they also use, this is the topic. So this is the hashtag. And there is a number here, right, 8. What that is there is we just have an internal notion for the topics. And so it says that these two relationships are based on the two names of people, and then the hashtag, and then within the hashtag what topic it is. So let us say if this person happens to be your premium customer, and if this person is not, right, now you have an opportunity to reach out if you have the way to engage with them on social media. So the key part is it's about engaging through the social media. You just can't do anything else. That's the best you got. And that's the kind of information we're trying to get with this. Okay? All right. So this network is a very a small part that I pulled together. I have seen as high as nodes like 10,000 nodes and a lot of relationships and so forth. So you marry that to the transactional behavior that the customers have already performed for you. So coming back to the first few questions that we asked, right? By now, I hope if you believe that the answers that I have are these, I think it made sense. Here is what we're thinking about. The key part here is you have to set some metric, right? How do I know did I get the right person? Because the answer that you are getting from most data mining applications it's a probable answer. I'm trying to find pattern matching. We think this was going to happen, but it's never always true. So you got to set what are my measurement targets. I've been in some industries in the past where when we do this kind of models, we set a specific test model. On most machine learning things, you have a test sample. You use what you learn from the test sample on your other samples, and then you can deploy that into your production systems. Okay? I believe that's it. Any questions?
In this presentation that you took us through, the most probable application is to do an outreach, like reach out to the customer through social media only. That's what your last statement was.
Yes. That was the goal because you don't have any information about right? You don't have any information about, let's say if this person is not your customer, you don't have any other information, right? So you could, that's the one. And in social media, if you have the Twitter handle, you can, you may be able to reach out to them. Right? That's just one example.
I was just wondering how customers react to being reached out to.
That's actually, it's a very good point. You're right. The governance in all that is very important, right? We never ever want to say, here is just go wild west, but don't do that. So if you have a proper governance, what happens is you're reaching out for a person. If you know for sure that a service is required, and if there is an engagement, I'm not talking about a selling process, right? This is about an engagement process. You're engaging with the customer. You're not blindly saying, hey, if you're my airline customer, here is a free coupon, right? That is, you're right, that's creepy. You're wondering, like, how do I know I'm going to go to this place, right? Here you start engagement process differently. And a lot of companies are trying to specifically address that through change management and so forth. So this has to be very carefully orchestrated. You're right. You don't want to use this information to reach out whomever you want to, right? So.
I have a statement, an observation to make, especially on Twitter. I haven't seen it yet, but I have a Twitter account and a few accounts. I experimented a couple of times. If you go and say, for example, I'm from India, and I go click on some aspect of India. Say, for example, there was an earthquake yesterday in Nepal, India. Right? So there are suggestions that come at you to look at certain other topics. I don't know if Twitter does it or somebody, they are trying to solicitate that tweet hash, hey, have you looked at this tweet? Have you looked at this tweet? So they keep coming at you. I couldn't figure out how to filter, where to filter my tweet account. So I think probably it goes to that, like you get bombarded, you get suggestions.
It happens with Gmail. It happens with Yahoo, everywhere, right? Everyone is trying to figure out, but this is a personal observation. What I do typically is on browsers, I'm very careful about closing down the browser before I go to the next one. And I think, there are a lot of things that happen in the browser level itself without having to, look at your tweets and whatnot. But this is, very responsible way we're talking about to engaging with the customer. You're right. This is not to say, here is how you can do what you need to do. We're talking about a premium customer because you do want to make sure that you may be able to reach your premium customer. You may be able to reach this person using your premium customer. You don't know that, right? So there are so many ways, and the organizations are actually thinking about how to do that better. So yeah, they understand the creepiness of the social media interactions, right? So, yes.
What types of customers are you looking at? And all Twitter users?
The
customers of a particular business?
The target customers for this application would be any enterprise that has a loyalty program. That could be airline or retail or what have you, right?
And what kind of transaction data?
So if you look at the airline, you have your purchase, the airline tickets and so forth, and you have clickstream analysis. They say, for example, before I bought this ticket, where all they clicked, what is the path. And so you have information about how they got where they got. So those are the transactions that they have. There's nothing to do with social media, but it's unstructured, but it is the transaction that they have. That's for the airline example. On retail, of course, market basket, right? What all the things that you buy becomes your market basket, so you know what you do and so forth.
How do you connect customers in transaction data with Twitter?
Very good. So what happens is, a lot of times when the companies engage, they have information about your email account and your Twitter ID. These are all voluntarily people share. So that's why you'll find out, I don't know, in some cases they ask, hey, do you want to mail your email receipt to you in email, right? So there are ways in which this information is found. And also there are some companies that will triangulate many information into that. Yes?
Well, I just from a consumer perspective, you found you're on a digital journey experience and you express yourself in session socially, boom.
Yes.
They're capturing everything about your digital ID, Twitter, whatever you went out, Facebook, they got it.
Yep. Yes.
So how do you expand this into other social networks? So Twitter is just one example.
Right.
And so what, do you do anything for Pinterest? I don't know, whatever.
No, our next thing is about using images,
Okay.
right? So we have some image processing algorithms to find similarity, but we haven't exactly laid the roadmap out. But basically, what we're thinking is anything that has a topic. Right now we're doing a conversation, so using hashtag as an example, but eventually it'll be mapped to a concept from anywhere else. Right. Yes.
So there's a lot of work going on, getting data, social media or whatever, and then doing some analysis and then prediction. What is the work going on reality check and feedback? Like on meetups, I have 15 people sign up. Yes, I'll come, and only 4 show up, but there's no data that they didn't show up. Like, I don't know, I've worked for some organizations. There are like 500 people who like the topic. When you organize a fundraiser, 2 people show up. Or just the false predicament. I'm looking for a pressure cooker, and because of Boston, I see ads about a bomb or a pressure cooker bomb. So what about the wrong predictions and the false analysis? Where is the loop being connected for the feedback to make accurate predictions?
Okay, so that's a good question. there's always in these things, there's a false positive we got to be very careful about. You are identifying, hey, I can apply this scenario, but it is incorrect identification. So in organizations, whenever they apply these, there is always a measurement of what is my, there is several measures like, recall, and then how many hits I have. And so there's a measurement of saying, if I am making this prediction or projection or recommendation, what is the next event that happens to that? That tells you whether are they responding to your suggestion that I'm making or not. And then you use that to pattern to tweak your models. Because that's what I said in the beginning. When we deploy this, we always start with a small test sample, and then you perfect your model. Because of this being a pure prediction, there is no right or wrong answer in a lot of cases. But if you send this kind of information to, let's say, 20% only responded, that tells you your model score. You're scoring not the conclusions, but you're scoring the models. A lot of times, organizations have multiple models they are testing, and so then you fine-tune and make the models a little bit better. And that's the reason why we want to check your expectations coming out of the proof of concepts and so forth. Okay. All right. Yes. All right. Thank you, guys. Appreciate it.